variations in temperature. So finally, grillage analysis. After having done all of this, you need to know all the load values, and finally you need to create a grillage model. So grillage model is not rather complicated, but rather determining analysis. Grillage analysis can be coupled with construction stage analysis. Construction stage analysis is basically trying to simulate the exact conditions of constructions upon a span. So if you see this figure over here, construction stage 1, 2, and 3. Okay, I'll show you a 3D model so that it is better understandable. So this is a construction stage model that I had made for Mumbai Metro. So this is construction stage 1. If you see properly, you'll see that these are girders: 1, 2, 3, 4, 5, 6, 7, and 8. Excuse me. So these are girders. In the first stage, I've activated all the girders. I've activated the bracings. These are the bracings. I've activated the splices. These are the splices. I've also activated all the supports. Over here are the supports. Okay. So this is actually a simply supported simulation. We're basically trying to simulate all the conditions that the span would experience while the construction is going on. Okay. As also, what you need to activate is the geometry, and second, you need to activate the loads. So what are the loads that are activated? The self weight of the girders only. Okay. In the second stage, I activated, if you see, there's some difference, right? So these are the members which are activated: and diaphragm, bracings, connecting bracings. Over here, they were not activated. So why I'm activating this is it is trying to replicate how the construction is going to proceed. Okay. So in this stage, I've activated with, along with the stage 1 activations, I've activated the extended bracings and the diaphragms, and the self weight of the added members. This is what I've activated. But in the third stage, I'll have to activate everything. So now it depends upon you as to how many stages you want to go, and as to the level of detail as to what you want. Okay. So in the third stage, I've activated the entire span. If you see, these are I-section girders. As also, these are merging tracks. These are merging tracks, and these are the girders. And I've resolved them into different segments. This is only to have a detailed, or you can say a more finer result to my analysis. So in this construction stage, I've activated all the geometry. I've activated all the stages, all the loads. So as I told you before, it can be coupled with construction stage can be coupled with different loadings. So over here, we are only talking about the dead load. So we will have 3 different models, wherein like model number 1, 2, and 3. So either you go for a model which incorporates the conditions of the loading conditions of all the 3 cases, or you have a single model. Either you have separate models, or you have a single model which incorporates all of them. So in my case, I went for different separately. So in my case, I had a different model for dead load. I have a different model for ideal and for live load. What happens is it reduces the level of complexity in your model. One single model does not have to handle so many iterations, or you can say load cases. So I prefer to have different models for all of them separately. So this is the this is the basic of this one. As I said, construction stage. You have to define it. You have to activate. What do we have to activate, and how we go about. Okay. So this is the line model, the 2D grillage model, and this is with the sections. And if you see over here, after the, oops, so sorry. Okay, after the bracing, after the splicing, the section is increasing. Okay, these sections are not as big as these ones. This is because we are at the center point, and we'll have a higher, since this being a simply supported one, so we'll have higher moment on this value. So we'll have a heavier section at this point. So more on this, I believe grillage analysis in itself, a very, very vast topic. So if we happen to have a session on grillage analysis, I'll go in great detail about how we choose a section, how we go about putting the loads, how we go about setting the construction stage and the loading. So more on that when we have a separate session on release analysis. So finally, the load combinations, how we go about load combinations is that the DBR has to specify what load combinations you need to take. Do you have to refer to a certain code, or do we have a separate guideline for this specific project? Okay, so typically they'll give you two or three combination like serviceability and ultimate state, as well as to check the SPC. So these are the load factors. So whatever load that you have, like for example, whatever if you're designing a peer, whatever that load you need to create a combination. Like this is combination 1, 2, 3, 4, 5, 6, whatever number of combinations. So maybe at the end this will give you a longitudinal moment of maybe 100. This might give you a longitudinal moment of maybe 50, 60, or 200. So whatever combination gives you a higher value, you'll take this and design your peer or whatever section you're designing. Okay, so this SLS load case is usually used for checking the structure, and ULS is used usually for designing the reinforcement and other aspects. So yes, I believe this is it. We'll wrap up with this one. So if you are interested, let me know, or you can let the organizers know as to what topic you can say intrigued you the most. You can have a separate session on that. If you want to have a further reading, I'll suggest these three books: Concrete Box Girders by Slides, and this Bridge Engineering Handbook. And the last one is Concrete Bridge Practice, because this is what I referred when I was designing a few structures, and these references. So yes, so if you've got, that's about it.